Okay, let us proceed now for the isentropic process. Okay, when you say isentropic process, it's an internally reversible constant entropy process of a working substance. It's also known as adiabatic process. Adiabatic process is a reversible process in which there is no heat. There is no flow, no flow of heat between the system and its surroundings. Q is zero. Okay. Under the PV plane, okay, pressure volume plane, as the pressure decreases, the volume increases. As the volume decreases, as the pressure decreases, the volume increases. As the volume decreases, the pressure increases. Inversely proportional. 1 to 2. Okay. Under the TS plane, the temperature entropy, even the temperature increases or decreases, the entropy remain constant. Okay. For the formula, relationship among the pressure, volume, and temperature, therefore, we have P1 V1 raised to K is equal to P2 V2 raised to K. Another formula, we have T2 over T1 is equal to V1 over V2 raised to K minus 1. Another formula, we have T2 over T1 is equal to P2 over P1 raised to K minus 1 over K. Letter B, we have the non-flow work. For the non-flow work, we have integral of P dV with the limits from 1 to 2. Therefore, we have P2 V2 minus P1 V1 over 1 minus K or equal to MR. Since your P2 V2 is also equal to mass times R times T, since V2 minus V1 MR T2 minus T1 from the ideal gas law. Okay, 1 minus K. Now, for the change in internal energy, that is equal to mCV T2 minus T1. While the heat is equal to 0. And for the change in enthalpy, that is equal to mCp T2 minus T1. And for the change in S, change in entropy, that is also equal to 0. Now, for the steady flow work is equal to negative change in enthalpy. If change in kinetic energy and change in potential energy is equal to 0. For letter H, for the negative integral of BdP with the limits from 1 to 2. Therefore, that is equal to K P2 V2 minus P1 V1 over 1 minus K. Example. A piston cylinder assembly contains 3 cubic feet of steam, 3 cubic foot of steam at atmospheric pressure and 230 Fahrenheit if it is desired to isentropically compress this gas to a pressure of 230 psig. To what volume? Must the gas be compressed? And what is the resulting gas temperature? Okay, now for the system, steam inside a piston cylinder. Assembly. Okay. given state 1 process state 2. Okay, for the state 1, we have the pressure 1 is equal to atmospheric pressure. Okay, therefore, the constant value, which is 14.7 psia. Then V1 is equal to 3 cubic feet. Then T1 is equal to 230 degree Fahrenheit plus 460. Therefore, that is 690 degree Rankine process, isentropic, P2, 230 PSIG plus 1470, 230 PSIG. Therefore, to get the absolute plus 14.7 equal to 24.7 PSIA. Okay, next, for the figure, we have the steam, then P1 is 14.7 PSIA. Next figure, steam, P2 is 244.7. Now, for K, for the steam, solution. For steam, we have the constant value of your K, which is equal to 1.329. Okay. The requirement is to find for the resulting gas temperature. Okay. First, we have your P1 over P2 is equal to V2 over V1 raised to K. Okay. And your V2 over V1 is equal to P1 over P2 raised to 1 over K. Okay, then your V2 is equal now to V1 P1 over P2 raised to 1 over K. Okay, where your V2 now is equal to V1 V2. V2 is equal to V1 is 3 cubic feet. 3 cubic feet times P1 is 14.7. 14.7 PSIA over P2 is 244.7. 244.7 PSIA. 244.7 raised to 1 over 3.29. V2 is equal to 0.362 cubic foot. Not yet. So let's put the 5 minutes. Okay, next, using the formula T2 over T1 is equal to P2 over P1 raised to K minus 1 over K. Wait, T2 is equal to T1 P2 over P1 raised to K minus 1 over K. Okay, we're T2 now. Substitute the values. T1 is 690 degree Rankine. 690 degree Rankine times P2 is 244.7 PSIA over 14.7 PSIA raised to 1.329 minus 1 over 1.329. Cancel PSIA. Hey, correction, this one is 1.329. 0.329. Still, V2 is 0.362 cubic feet. Okay, this one is equal to T2. Is equal to. Okay, therefore T2 is 1,384.18 degree Fahrenheit. Okay, requirement is to what volume? Therefore, and what is the resulting gas temperature? Therefore, your V2 is 0.362 cubic feet.